All right, good morning. And today we're going to learn about the law of sines. We've already done law of cosines, we've done area of a triangle, and we're going to talk about the law of sines. If you recall, law of cosines from our notes last week looked like this. The law of cosines was this formula. It had a cosine of an angle in it. And it was used for these two cases, side angle side and side side side, when you were given two sides and the angle between them, or when you're given all three sides. Okay? So let's just keep that in mind. I'm going to put that as a reminder at the top of the page. Law of cosines we use for the cases side, angle, side, and side, side, side. Okay, and we're going to talk about today, when do we use law of sines? We're going to put that down here. Okay, but before we do that, what we're going to do is we're going to talk about what is the law of sines. Well, the law of sines is derived directly from your area of a triangle formula. So also last week, remember when we did this, the area of a triangle, we proved this, but what we found was the area of a triangle is 1/2 BC sine A. These two, B and C, those are lengths of two sides of the triangle. Sine of the angle A. Angle A is the angle between B and C. Okay, this is for any triangle ABC. Triangle ABC. You could have a triangle DEF or a triangle XYZ, okay? And then you would just substitute the letters. So 1/2 X times Y times the sine of the angle between X and Y, which would be angle Z, okay? But for our purposes for the formula, we're going to use A, B, and C. Okay, this is equal to this, 1/2 AB sine C, that's sides A and B, sine of the angle C, which is the angle between those two sides, 1/2 AC sine B, B is the angle between A and C. Okay, so we're going to first write this equation down, setting all three of these equal to each other. Okay, so 1/2 AB sine of angle C equals 1/2 AC sine of angle B equals 1/2 BC sine of the angle between B and C, which is angle A. Okay, I'm going to divide all three of these equations by 1/2. Those will go away, and I've got AB sine of angle C equals AC sine of angle B equals BC sine of angle A. This is no longer the area of a triangle, but these are all equal to each other. We took three things that were equal. We got rid of the 1/2, multiplied all of them by 2 or divided by 1/2, however you want to look at it. Now we've got this equation. We're going to divide everything by A times B times C. A times B times C, A times B times C. Notice what happens. Here the A times B cancels. Here the A times C cancels with A and C. B times C cancels with this. And what you're left with is sine of angle C over side little c equals sine of angle B over side little b equals sine of angle A over side little a. And that, my friends, is the law of sines. That's all there is to it. We just derived it. It was quick. Okay. Now, when do we use it? Well, let's look at a couple examples and see how it works. Okay. The first example, in triangle RST. So I'm going to draw a triangle. I'm not even going to worry about drawing it to scale, and you'll kind of see why as we go further. Okay. But I'm just going to draw a triangle RST. Once I solve for all the missing sides and angles, it would be easier to get an idea of exactly what this triangle would look like to try to draw it to scale. Angle R is 78. Angle T is 39. And TS, side TS, that's TS, which is actually side R, little r, is equal to 19. You can call it little r or you call it TS or ST. That's going to be 19. Okay. Now, this is the case where you have an angle, and then a side. So this is the case angle, angle, side. Now, before we solve this, I want to compare this to the next case. This is triangle ABC. Given angle A is 102.4. Angle C is 16.7. There's some missing information. So I'm going to make an executive decision, and I'm going to say we're also given side little b is equal to 12. Okay, I'm going to highlight this. Missing information, typo. So without this video, you would not be able to do this problem. But missing information, we need this information. Little b is 12. Okay, so little b is going to be the side across from angle B, so that's 12. So this is the case angle, side, angle. You have two angles, angle, and then side, and then angle. This one you have the side that's in between the two angles. This one you have a side, but not the side in between the two angles. Okay. Now, before we even use the law of sines, if you have two angles in a triangle, you can always find the third angle because you know the angles of a triangle add up to 180. So if I did 180 minus 78 minus 39, I'm going to get 63 degrees. I didn't even use law of sines, law of cosines, use nothing other than knowing what you knew back in geometry. Okay, the angles add up to 180. That's the easiest way to find the other angle. Okay, down here, 180 minus 102.4 minus 16.7 is 60.9. I would kind of argue that these two cases for our purposes here are kind of the same, so we're going to treat them the same. The reason I say that is any time you have two angles of a triangle, you really have all three, whether you had the side in between the two angles or the side that was not the side in between the two angles. Once you have two angles of a triangle, the third angle is fixed. So these two cases we're going to treat the same, and we're going to use law of sines for both of these cases. Angle, angle, side, and angle, side, angle. Because really, in either of those cases, you really have three angles in one side. Three angles in one side. Okay? Now, this definitely fixes one triangle. We've got three angles. I know that this is 19. I know that this is the biggest angle, so 19 is the biggest side. 39 is the smallest angle, so this side, little t, is going to be the smallest side. It says it finds RS. RS is this. RS is really little t. Okay. So now to set this up, remember what the law of sines is. Sine of an angle over the side, and this is the side across from this angle. So you've got pairs. You've got an angle, a pair of an angle and a side. Angle R and side R. Angle S, side little s. Angle T and side little t. Here we need to find this one. So we need to use this pair. Sine of an angle over a side. We're going to sine of 39 over little t, or over RS, whatever you want to call it, is equal to. And then we definitely want to use this pair. We have to make use of the pair of an angle with its opposite side where we have both of them. So sine of 78 over 19. Okay. Yes, this would also be equal to sine of 63 over s, but we don't know s, so that's not going to help us as much. We're going to have two unknowns if we use that. Okay. Now to solve this, you've got a t, and everything else you can plug in your calculator. So we're going to cross multiply. When you have two fractions equal to each other, you can cross multiply. So that's going to be 19 sine of 39 equals t times the sine of 78. Divide both sides by the sine of 78. That cancels. T is going to be equal to this thing. Okay, you can plug that in your calculator. I would definitely suggest trying that, but I've already done it. So to check your answer, what you get is 12.224 inches. Okay, we could find the other side for practice. We could find, this is not doing great. Let's my pencil. Okay, I'm going to try another pencil. Okay, but you can read that, 12.224 inches. Kind of makes sense. This would be 12.224. It at least passed the test of the smallest side should be across from the smallest angle, and that side is smaller than this side, which is biggest angle. So this side should be in between, because that's the middle angle. This should be the middle side. So we could solve that for practice. Okay, but let's go to the next one. Here, it doesn't even tell us what to solve for, so I'm going to say solve the triangle. And when you solve a triangle, it means find all missing sides and angles. Okay, find all missing sides and angles. Okay, so we already found this missing angle. So we've only got two sides to find, little a and little c. Okay, so we definitely have to use this pair, the angle and the opposite side that we have. So that's going to be sine of 60.9 divided by 12. It's sine of an angle over the length of the opposite side is equal to, let's find this one, sine of c over c. So sine of 16.7 degrees over little c. Multiplying, you're going to get c, cross multiplying c times sine of 60.9 equals 12 times the sine of 16.7. Okay. So this is not, that glare is not good. Okay. I think if I put it, you can see it a little better. Okay. So now solving for c, we're going to get c equals 12 sine of 16.7 degrees over sine of 60.9 degrees. And c is going to be equal to 3.946. Okay. So this is 3.946. Again, when it doesn't specify, give 3 decimal places. Okay, now let's find a. So I'm going to use this pair again. I still have this sine of b over b. So sine of 60.9 over 12. But now I need to solve for that. So sine of a over a equals sine of 102.4 degrees over a. So solving for a, cross multiplying, a is going to be equal to 12 sine 102.4 degrees over sine of 60.9 degrees. And a is equal to 13.413. I like to do a quick check. Is the biggest side across from the biggest angle? It is. Is the smallest side across from the smallest angle? It is. Perfect. So it looks good. Okay. Now we're going to go to the next page. We've got one more case. So we're going to use law of cosines when you have side, angle, side, 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 side. Law of sines when you have angle, side, angle, angle, side, and angle, side, angle. Okay. Now law of sines, the ambiguous case. Remember, there was that one case in geometry where you couldn't use, to prove triangles, prove congruent triangles. You had these theorems. You had hypotenuse, leg. You had side, angle, side. You have angle, side, angle. You had angle, angle, side. You had side, side, side. The one that you always wanted to try that didn't work was side, side, angle. There's a reason that one didn't work. Okay, so here we're going to talk about why it didn't work. I'm going to draw this in a very specific way to kind of demonstrate why this doesn't work. Okay, so when you've got, I'm going to draw a side here, and I don't know how long it is. This is going to be the side that I don't know. But I do know this angle, angle A, and this is 35 degrees. Let's try to kind of draw that to scale just to demonstrate. That's about 35 degrees. Okay, let's make this up here C. And this side over here, let's make, if this is going to be side B, this would be 15. And if this side is 11, 11 is going to be a little shorter than 15. Let's kind of draw it that way. Maybe that's 11. Okay, so I've got this 35 degrees, this side and this side. I don't know this side. I don't know the length of this side. I don't know this angle. So this, think of that as a hinge. This could swing around. And I don't know where this hits here because I don't know this side. Now I drew it this way, side, side, and then an angle. But who's to say I couldn't have drawn this 11 over here? Okay. If I drew a second triangle, this would be B. And instead of drawing it this way, I drew it. Let's draw this the same. So here's my A. This is still 35 degrees. Let's make that 15. And this side's still 11, but instead of going over here to draw my 11, I'm going to go this way to draw my 11. Okay? And then I'm going to put the B side over here. Are these two triangles congruent? Well, clearly not, because this angle is clearly obtuse, angle B, and this one's clearly acute. But I've got a side congruent to a side. I've got another side congruent to another side, and then I've got an angle congruent to this angle. I've got side-side angle. You were never able to use side-side angle to prove congruent triangles for this very reason. They're not necessarily congruent, okay? So if we're given this information, I want to find angle B, well, angle B might be acute, it might be obtuse, okay? And sometimes this is not even possible. Sometimes the second triangle is not possible, okay? So here, I think I kind of already answered this question, but you can construct a triangle with a compass and a straight edge when given 3 parts of the triangle, except for 3 angles, of course, because that's also one you wouldn't have in this list. Which of the following sets would result in an ambiguous case? When you have 3 sides, think about if you've got 3 sticks. That was 4 units long, 5 units long, and 6 units long. There's only one triangle you can make, right? So that would not result in an ambiguous case. 2 sides and an included angle. Think about having 2 sticks. One stick is 4 units long, one is 6 units long. And then they gave you the included angle, so this angle was fixed. Well, if they told you how big this angle had to be, you would only have one option to draw the other side. That would be fixed. Now, 2 sides and a non-included angle. Okay, that's what we had up here. 2 sides and a non-included angle. This one stands out. This one's ambiguous. Okay. 2 angles and a non-included side. Well, if you've got 2 angles, if you have 2 angles, though, you really have all 3 angles. If you had to fix this angle and this angle, you've already fixed the third angle, right? They don't have to be congruent to each other. But once you've done that, you can't prove it's congruent to another triangle with the same angles because it could be bigger or smaller. But then once you fix one of 2 angles and a non-included side, once you fix one of the sides, well, then you fix the triangle. So C is the correct answer here. That one would result in an ambiguous case. So we're going to do a couple practice problems. Okay, and here's how you approach a problem like this. Let's go back here and fill this out. So the other case here is side-side angle, but this is its own case, the ambiguous case. And when you see ambiguous case, the first thing you do is you're going to draw a second triangle. Okay. So let's go back to this problem. In triangle ABC, find the measures of angle B and angle C that satisfy the given conditions. Draw diagrams to help you decide whether 2 triangles are possible. Remember that a triangle can have only one obtuse angle, okay? So here I drew them to scale. Down here, I'm not going to draw them to scale because it's tough to know exactly what they're going to look like. And it's tough to know where everything should be, okay? I kind of knew this one ahead of time, so that's why I drew it, to make a point. I'm going to have triangle ABC. So I'm going to draw a triangle ABC. I get this problem. Okay, angle A is 62 degrees. Side A is 30. The 30's over here. Side B is 32. So now I identify the case. Identify which case is it. Okay, because we want to know, am I going to use law of sines or law of cosines? Well, this is side and then a side and then an angle. It's not side, angle, side. I don't have the angle in between them. It's side, side, angle. Okay, once you see side, side, angle, you should have a little alarm beeping off in your head and going, uh-oh, ambiguous case, ambiguous case. First thing you do with the ambiguous case, you draw a second triangle, okay? First thing you do with ambiguous case, draw a second triangle. Okay? Because there might be 2 triangles that work with those values. Okay, so we're going to draw a second triangle. I'm not going to try to draw it to scale because I haven't found all the sides and angles. I don't know what it's going to look like. But what I do know is the given information all has to be the same. So angle A is still 62 degrees. Side A is still 30. Side B is still 32. You want to fill in all the information that you have. Okay. Now I'm going to solve. I'm going to use the law of sines. I definitely want to use this pair, sine of A over A. So sine of 62 over 30 equal, what do we want to solve for? Well, we don't have angle C or side C, so let's leave that alone for now. Let's use angle B and side B. So sine of angle B over little b, which is 32. Okay. Let's cross multiply. 32 times the sine of 62 equals 30 times the sine of angle B. Now, please recognize that sine of B, you can't split that apart. That's all one number. Sine, SIN, is just an operation. You can't split that away from the B. So we have to get the sine of B by itself. Divide both sides by 30. The sine of angle B is equal to this thing. Plugging that in your calculator, you get 0.9418. Okay, so those cancel, plugging this in, 0.9418. Okay, if you do sine inverse of 0.9418, okay, remember to solve this, you do sine inverse. You change sine to sine inverse, you swap the input of the output, 0.9418 is equal to angle B, so angle B equals, what do you get? 70.3579. Okay. Now I do encourage you to stop the video, practice these, practice plugging them in, make sure you're plugging them in correct. I already did these ahead of time to make the video go a little quicker. Okay. But here's where there's an issue, and here's where you might miss a step. Okay. So if the sine of an angle is positive, think back to what we did with the unit circle. If the sine of your angle is positive, you could be in quadrant 1 or quadrant 2. It's a unit circle. My y value is the sine of the angle. This would be 0.9418. This would also be 0.9418. This vertical, the y value, okay? Or opposite over hypotenuse, which is the sine of your angle. My reference angle is 70. I'll just put the 70 in there. I don't have a lot of space here. This one's also 70. So my angle B is either 70, but it could also be this one over here, 180 minus 70, or 180 minus 70.3579, which is equal to 109.642, okay? You might want to rewind that if you just missed that. We real quick got two different answers for angle B. The first triangle, we'll put this one, 70.3579. Or angle B equals this, 109.642. 109.642. Okay? Got two different answers. The reason, again, that you have two different answers, we solve. Sine of my angle is 0.9418. Well, there's not only one angle that satisfies that. There's actually an infinite number of angles that satisfy this equation. Okay? Remember, if we solve for this, we'd be getting both of these answers, and we'd be adding 360K to both of those answers. We're not going to add 360K because an angle of a triangle can't be this number plus 360. Okay? But we do want this one. This angle here is going to be bigger than 90, but less than 180. It's going to be an obtuse angle. Okay, so we've got this and this. Now, to find the other angle, we would just take these two, add them up, and subtract from 180. That's going to give us 47.6421. And this one over here, notice this almost gets you to 180. 109 plus 62 is going to be like 171 point something. We get 8.3529. Okay. So we haven't completely solved the triangle, but it didn't ask us to. It said find the measures of angles B and C that satisfy the condition. There are two answers. This triangle, B would be this and C would be this. This triangle, B would be this and C would be this, okay? If you had to solve for side C, you could. You'd do law of sines again. Sine of this angle over little c equals sine of 62 over 30. You'd have to do it again over here. Notice this angle's bigger. This side's going to be bigger in this triangle than this one is. Okay? Okay, let's go to the next one. We're going to see one more example. So you've got angle A. This is again triangle ABC. Draw, which is angle A is 43 degrees. Little c is 16 millimeters. Little a is 24 millimeters. Okay, so you've got a side, and then an angle. Ding, 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 that alarm should be going off. This is the ambiguous case. What do you do? When you see that it's the ambiguous case, you immediately draw a second triangle. Don't worry about drawing to scale right now. I didn't give you a ton of space here. You might want to do this on a separate page. Everything, all the given information has to be the same. Okay. Now I'm going to use the law of sines. I have to use this pair, sine of A over little a, because I have both. I'm not going to use B. I don't have angle B or side B, but I'm going to use this one. Okay. So I've got sine of 43 over 24 equals sine of C over 16. Okay. You can cross multiply, or you could really just think about multiplying both sides by 16. Then these cancel. You've got the sine of angle C by itself, which is equal to 16 sine of 43 degrees over 24. So the sine of C, plug that in your calculator. Sine of C equals 0.4547. Okay, remember on your unit circle, if the sine of your angle is positive, that could be in quadrant 1 or quadrant 2. So this would be a y value of 1. This would be a y value of about 1/2. So it's going to be probably over here, kind of a smaller angle. For my y value, or the sine of my angle, to be 0.4547, 0.4547. Of course, that's if it's a unit circle. So let's do sine inverse of this thing. 0.4547 equals, plugging that in your calculator, you're going to get 27.0434. 27.0434 for my first one. I'll put that in the first triangle for angle C. So remember, this is angle C. That's going to be 27.0434. Or, and that's this angle right here. That's 27, that's 27. But we want to find from standard position this angle, which is going to be 180 minus 27. So 180 minus 27.0434, which is equal to 152.957. That's angle C. We'll put that in the second triangle. 152.957. Okay, let's go to the first triangle. First thing we're going to do, we have to find angle B and C. We found angle C for both. Angle B, we're going to subtract these from 180. For the first triangle, you get 109.957. Do that on your own. And for this one, look at what happens here. 43 and 152.957. These add up to almost 200, well over 190. This one's not going to be possible. If you solved for this, if you took 180 and subtracted these two, you're going to get a negative angle here. I got negative 15.9566. Okay, that's not possible. You say no, second triangle. Possible. You only have one triangle, okay? It is possible to have no triangles, okay? And the way that might happen is, let's say, and I'm going to draw this exaggerated, but let's say this angle were 35, like in the first example. Let's say this side were 15, like in the first example. And what if they told us this other side over here was 2. Okay. When you write it down, this was A, C, and B. It would say little b equals 15, little a equals 2, and angle A equals 35. You might not notice that this doesn't work out. You might not notice that right away. But when you draw it, you can see how this is not physically possible. If I can't bring this down by shortening this angle, there's no way this is going to reach. And I don't know how big this is. I can extend it. I can swing this back and forth, but no matter how I swing this back and forth, it's not going to reach down here. So sometimes this side's not long enough because of this angle, and you can't bring it down. Okay, so that's a case it is possible to get no triangles possible. Okay, that's just an aside. Okay, all right, and that's it. So your homework tonight is to do the Delta Math assignment that I have already assigned, and I will post these notes. Thank you all for watching, and I will see you soon.